Today, I'm now going to discuss some important and different formula of de Broglie wavelength. So, all of you know that what is the formula for de Broglie wavelength? All of you know that is if lambda is the wavelength and h is the Planck's constant and p is the momentum of the particle, then the de Broglie wavelength formula equals lambda equals h by p. But when solving the numericals or any problems, there are different types of question where, where there are different use of de Broglie wavelength. Means in some question they are asking you to calculate the thermal de Broglie wavelength, average thermal de Broglie wavelength. Then different formula of de Broglie wavelength will be used. And suppose in some question they are asking you find de Broglie wavelength. They have given you that condition that charge is accelerated by a potential V. There another de Broglie wavelength formula will be used. So today we will discuss different aspects of de Broglie wavelength. So first formula that we know, it will be very helpful for all the students. So first formula we know that de Broglie wavelength lambda equals h by p. Everybody knows it. Where h is a Planck's constant, h value is given by 6.625 into 10 to the minus 34 joule second. Okay, this formula all of you know. But if some condition is given such, which condition is given? For if it is given in such way, let me change the pen color, that you are given non-relativistic case. Non-relativistic case means if you are given that velocity of the particle is very less than c. C is the speed of light. C is the speed of light. If we are given that velocity of the particle is very less than c, then what condition? What de Broglie wavelength we will use? So let's discuss that. So for non-relativistic case, that is if velocity of the particle is very less than c, then we will use the formula of de Broglie wavelength lambda equals h by root 2 mk. K is the kinetic energy of the particle, m is the mass, k is the kinetic energy of the particle, that means p square divided by 2m0, m is the rest mass. So for non-relativistic particle, the formula we will use the de Broglie wavelength, that is lambda equals h by root 2 mk. That is the formula. Now second case arises when they are asking you that if kinetic energy is given such that kinetic energy is given 3 by 2 kVt. 3 by 2 kVt kinetic energy is given, then the formula turns what? The formula will be turned into lambda equals h by root 3m kBt. Yeah, the formula will be turned into h by root 3m to kBt. So when the kinetic energy is 3 by 2 kBt, then the de Broglie wavelength formula will be given by h by root 3m kBt. Now these are for relativistic case. If the case is such that if V nearly equals C, that means relativistic case is coming. If relativistic case is coming such that if velocity of the particle is nearly equal C, then the de Broglie wavelength formula will be lambda equals h by p, that means h by root over t into t plus 2m0 c square. Let me write properly. For relativistic case, lambda equals h by t plus t 2m0 c square. T is what? T is kinetic energy for relativistic particle. Kinetic energy for relativistic particle is what? T equals m minus m0 into c square. Let me write in clear page. So this is a relativistic particle case. This is a de Broglie wavelength for relativistic case, where T is the kinetic energy. In relativistic case, that is m minus m0 into c square, where m0 c square is the rest mass energy of the particle, and m equals m0 divided by 1 minus v square by c square. So for relativistic case, what we got? For relativistic case, de Broglie wavelength will be h by root over t plus 2m0 c square. That is a case. Here whole over root will be there. Now the another case is coming such that if a charge is accelerated by a potential v, a charge q is accelerated by a potential v, then the de Broglie wavelength will be such that lambda equals h by root 2m qv. Yeah, means when the de Broglie wavelength is suppose such that you have potential v given and the charge is given and the charge is accelerated by the potential v, charge is accelerated by some certain potential v, then the de Broglie wavelength will be lambda equals h by root 2m qv. And the last and very much important one, that is if thermal de Broglie wavelength average is being asked, thermal de Broglie wavelength formula. If they are asking you average thermal de Broglie wavelength, average will be there, average thermal de Broglie wavelength, then what formula we will use? We will use lambda equals h by root 2 pi m kbt. Let me write clearly, properly. Lambda equals h by root 2 pi m kbt. So this is a formula for average thermal de Broglie wavelength, and that's it for today. So these are some important formula and the different aspects of using or applying de Broglie wavelength formula which we will use. There is another important de Broglie wavelength formula. If voltage is given, note it down. If some voltage is given to you from the division German experiment, we have got that, then lambda will be root over 150 by v. So these are some important formulae of de Broglie wavelength. Note it down. These are very much useful for solving numericals of different questions of de Broglie wavelength. So that's it for today. Thank you for patiently watching. Bye.